Alright guys, so today we're on day 5 notes. We're going to be learning how to do division of polynomials by a monomial. If you remember, a monomial is just one term polynomial. Okay, we're going to start here at the top. Remember, our learning target today is I can find and factor out the greatest common factor, divide by a monomial. Let's start with our warm-up. I'm going to go to the top of the screen here. We have x to the 8th over x to the 3rd. You might have to think back to our unit that had to do with exponents and what we do when we have the same base being divided by a lower number exponent. If you remember, we're going to subtract these exponents, okay? So if I have x to the 8th over x to the 3rd, that's going to leave me with x to the 5th. Okay, thinking along the same lines and moving over here, I've got 14x to the 8th over 2x to the 3rd. This is the same problem except there's a 14 and a 2 as coefficients there. Remember, if I have this, all I'm going to do is divide those coefficients. So 14 divided by 2, this is just my simplification or reducing. Okay, I'm going to end up with 7. So it'd be 7 over 1. I can just assume that's 7. And x to the 8th and an x to the 3rd, that's the same thing we just dealt with. We're going to subtract the exponents. That's going to be x to the 5th. Okay, well, what about if I'm trying this one over here? This is 10x over negative 2. Now, this bottom one does not have any exponents in it, but what it does have is a single term monomial, negative 2. We have 10x at the top. I know I can simplify 10 over negative 2. That's going to turn into negative 5. My exponents aren't going to change, so I'll have negative 5x. One more here in our warm-up. I've got 8x minus 4 all over 2. Okay, well, this just means I can divide both of those top terms by 2. So I'll simplify that. If I have 8 divided by 2, that's going to be 4. I can't do anything with my x because there's no x on the bottom, so that x is going to stay and come with. And then I have a negative 4, because remember we had this subtraction sign right there. And I'm going to have a negative 4 divided by 2. That's just going to be a negative 2, or minus 2. Okay, so using what we just did, we're going to try to bring that into what we're going to learn today. Okay, so how do I divide polynomials by a monomial? Okay, well, if you remember when we were multiplying polynomials, we multiplied our coefficients, and then we added our exponents. This is just a little bit different. We're going to do the reverse. For step 1, we're going to divide our coefficients, and we're going to subtract our exponents. Okay? So just using those two steps, let's see if we can complete the rest of the examples we have in the notes. Let's try the first one. Example 1. Simplify each polynomial. Our first one says 5x squared minus 125 all over 5. Well, this means that both these terms on the top can be divided by my number on the bottom, 5. We know that they can go into both of those evenly. So what I'm going to do is 5x squared divided by 5. I'll divide my coefficients. That's going to be 1. And subtract the exponents. Notice there's no variable and no exponents here, right? So I can't change my exponent at all. So if I'm just going to do the 5 divided by 5, that's going to be 1x squared, or just x squared. Let me change my squared here. It just looks like a 7. And then I'm going to have negative 125 divided by 5, which is negative 25. Now, there is a way you can check this. You don't need to do this every time, but if I just wanted to be sure, the opposite of division is multiplication, right? So if I wanted to put this whole thing in parentheses and multiply by 5, I should get the same thing that we had on the top, right? And then if I did that, I would distribute the 5. I'd get 5x squared minus 125. So we know we're doing the right thing. Sorry, I'll put the correct answer there. We're going to have x squared minus 25. Let's go to example B. I've got 2x squared minus 18x plus 36 all over 2. Again, I'm going to just take all of these top terms and reduce them or simplify them by dividing by our bottom term, 2. Let's try it. 2 divided by 2 is just 1. There's no exponent on the bottom, so that's going to remain x squared. Then I'm going to take this negative 18. I'm going to put that one divided by 2. That's going to be a negative 9. The x comes with it because there's no x on the bottom. Now it's time to do the 36 divided by 2. That's just going to be a positive 18. So my final answer there will be x squared minus 9x plus 18. All right, let's move on to example C. Negative x squared minus 7x minus 8 all over negative 1. This one is actually pretty simple, knowing that anything divided by 1 is just itself. The only difference is this is a negative 1. Okay, so let's just turn everything negative. I have a negative 1x squared divided by negative 1. That's going to result in a positive x squared. And then I'm going to have negative 7 divided by negative 1. Negative divided by negative is a positive, so I'll have positive 7x. Notice I bring these x and the exponents they have at the top with, because there is no x on the bottom. Then I've got negative 8 divided by negative 1. Negative divided by negative is a positive. No variables to worry about, so I've got x squared plus 7x plus 8 for letter C. How about letter D? A lot of bigger numbers here, but we're just going to approach it the same way we have all the other ones, okay? Let's start with our top terms. I've got 18r to the 5th plus 36r to the 4th plus 27r to the 3rd, all over 9r. This is the first time in our examples that we've seen a variable in the denominator. Just look back at our rules. We divide our coefficients, subtract the exponents, stick to those basic rules. Let's see if we can simplify from there. Okay, so I've got top term of 18r to the 5th. We're going to divide that by 9r. I'll divide my coefficients, which is 18 and 9. That's going to give me 2. I'll subtract my exponents, which I have 5. And because there's nothing written here, doesn't mean it's 0. Remember, we assume it's a 1. So I'm going to have 5 minus 1, so it's going to be 2r to the 4th. Okay, what about here? I've got a term of 36r to the 4th divided by 9r. Same thing, 36 divided by 9 is going to be a positive 4. I've got r to the 4th, and on the bottom is r to the 1st. 4 minus 1 is 3. Sorry, I forgot my r. And then our last term is 27r to the 3rd. Divide that by 9r. 27 divided by 9 is a positive 3. R to the 3rd divided by r is going to result in r squared, because we have exponent of 3 and 1, subtract to get r squared. So final expression of 2r to the 4th plus 4r to the 3rd plus 3r squared. Okay? All right, now we've got 9x to the 5th plus 9x to the 4th plus 45x to the 3rd all over 9x squared. Now it's getting a little more involved, having variables to the degrees. Same rules apply. It's no different than what we've been doing, okay? So let's divide our coefficients. In this case, it's going to be 9 and 9. If I divide 9 by 9 as just itself, that's going to be 1. And I have exponents of 5 and 2. Subtract those to get 1x to the 3rd, or just x to the 3rd. Let's go to the next one, 9x to the 4th over 9x squared. 9 and 9 again is going to be 1, but this time I've got x to the 4th over x to the 2nd, so I'm going to do 4 minus 2 to end with x to the 2nd. Remember, I can't combine these terms because the degrees are different. I have a degree of 3 for my leading coefficient, my first term, and a degree of 2 for my second term. Okay, so those have to stay the same and I can't combine them. Here I've got 45x to the third. I'm going to divide that by 9x squared. 45 divided by 9 is 5, positive 5. And I've got x to the third and an x to the second. I'll subtract 3 minus 2 to get 5x to the first. I'm just going to leave it as 5x because remember, that 1 is there, but we don't need to write it. You can if you want to. It's not necessary. So we'll have x to the third plus x to the second plus 5x. All right? To example F. 9x to the third minus 18x squared plus 27x. All over negative 3x. All right, so now they've got a variable in here and a negative in the denominator. Same rules apply. Let's go through it the same way. I've got 9x to the third. I'm going to divide that by negative 3x. 9 divided by negative 3. Divide my coefficients to have negative 3. Subtract my exponents. There's going to be a 1 right there, right? Subtract 3 and 1 to get x to the second. Then I've got negative 18x squared divided by negative 3x to the first. Negative 18 and negative 3. If I divide those, I'm going to get a positive 6x squared minus x to the first, or sorry, divided by x to the first, meaning we're just going to subtract the exponents of 2 and 1. So that's going to be 6x. Now here's the first time we're actually going to get some variables that cancel out. Notice that right here there's no degree, so we know that there's a 1, same as the bottom. So I'm going to still divide my coefficients. So 27 divided by negative 3, that's going to net me a negative 9. And if I subtract these exponents, 1 minus 1 is 0. You remember anything to the x or anything to the power of 0 is just 1. So I don't need to write those down. So we would actually have like an x to the 0 here, but because that's just 1 and it'd be multiplied by a negative 9, which would end up as itself, we just don't even need to write it there. So our final expression will be negative 3x squared plus 6x minus 9. So now we've had a few examples on how to do it when they have given us the greatest common factor. What about when they don't give us the greatest common factor? Okay, so what about when we don't have the greatest common factor? We need to find it ourselves, okay? So let's try to find that. We'll factor it out of what we're given. And then we're going to factor each quadratic expression completely. Okay, so 2x squared minus 8. What I like to do is look for the lowest coefficient that can go into every single term evenly. So for example, here we have 2. I'm going to see 2 is the lowest and see if that can go evenly into the other terms. Here's negative 8. Does 2 go into 8? Yes, so I can use that one. What I can't use is a variable to factor out because there is no variable attached to that second term. Okay, so I'm just going to leave it as the 2 that we're taking out. I'm going to take out that 2, do it the same way we just did all the other ones. So divide my coefficients. 2 divided by 2 is 1, so that's just going to be x squared. It's going to remain x squared because there's no exponent to subtract, right? And then I'm going to have negative 8 divided by 2, which is going to net me a negative 4. Okay, but we're not done yet. Remember, it says factor each quadratic expression completely. If you notice here, we have a difference of squares. If I do the difference of squares pattern, I have x being squared, and then I have a 2 being squared. Right, so it's going to end up as x plus 2, x minus 2. And that would give us our x squared minus 4. Okay, but this is not going to be the final expression we write out. Okay, remember, we took a 2 out of there. So to factor it completely, our final expression would be 2x plus 2, x minus 2. Okay, let's move on to the next one. B, 4x squared plus 24x plus 36. I'm going to take a look at my lowest term. It's a 4. All right, does 4 go evenly into 24? Yes. Does 4 go evenly into 36? Yes, it does. So I'm going to use that one. Now, this one does have a second term with a variable in it. However, this third term still does not. so I can't factor out a variable yet either. So I'm just going to let it be that 4. All right, let's do 4 divided by 4. That's just 1. X squared is going to remain the same because there's no exponents to subtract. I'm going to go 24 divided by 4. That's going to be a positive 6. Take that x with me because I can't subtract an exponent on that one either. And then this one is just 36 divided by 4. That's going to be 9. Okay? So looking at this now, you're going to see that this is a perfect square trinomial, and we want to rewrite that if we were to factor it out as a squared plus 2a times b plus b squared. Now, I'm not going to make you rewrite the whole blank model before we rewrite it, but it's just going to be x squared plus 2 times, my a value is actually going to be 1, or x, times the b value being squared, which in this case would be 3, and then it would be 3 being squared. Okay, so if I were to simplify this out, would that be x squared plus 6x plus 9? Would it be the same thing? Yes, it would. So that expression factored out will end up being x plus 3 squared. But we can't leave it like that because remember we took a 4 out of that. So it's going to be 4 times x plus 3 squared. Let's try another one. 3x squared minus 48. I'm going to take this 3. Can 3 come out of 48 evenly? Yes, it can. So I'm going to divide by 3. I'll have x squared minus 16. Again, we've got ourselves a difference of squares. So this is going to be x being squared and then 4 being squared. So my expression would end up being x plus 4, x minus 4, and that whole thing would be multiplied by 3 because remember we took a 3 out of the regular expression. So factored out completely would look like 3 times x plus 4 times x minus 4. Okay, let's go on to D. This one might look a little easier because it's nice and even numbers. So we have 10x squared minus 1,000. I'm going to divide that all by 10 because I know 10 is going to come out of there because it ends in a 0. Okay, so 10 divided by 10 is 1. I'll end up with x squared minus 100. Again, we've got a difference of squares. X being squared and 10 being squared. So actually, I'm going to go ahead and rewrite this up here so I got a little more room. That's going to end up being x plus 10 and x minus 10. And again, to rewrite it, I have to multiply both of those by 10 because we took a 10 out of there to start. Okay, so when you're rewriting it, you just need to rewrite your final factored expression times what we factored out at the bottom. Okay, moving to E. I've got 2x squared plus 8x plus 8. I'm going to factor out a 2 because that's going to come out evenly into this term, and that term. I'll have x squared plus 4x plus 4. Zoom in a little bit here, give us more room. Okay, x squared plus 4x plus 4. This is going to be one of those perfect square trinomials where my a term of x is being squared. This is going to end up being 2 times my a term and b term, and then 2 being squared again. So I'll end up with x plus 2, x plus 2, and then I need to put both of those multiplied by 2 as well. So your final expression is going to be 2 times x plus 2 times x plus 2, or 2x plus 2 squared. And last but not least, we'll go to F. This one we actually can factor out a variable because we have a variable in the first term and in the second term. That's all the terms, so we can factor out a variable. Now, how many variables can we factor out? Whichever one, but the highest value exponent that both terms have is the value exponent we can factor out. In this case, the second term is to the first degree, and because that is the lowest term of all of them, that's the highest one we can factor out. Okay, so it might make a little more sense once I start to do it here. So I'm going to have 2x to the third minus 98. Still need to factor out the coefficient values too. In this case, it's a 2. Does 2 go into negative 98? Yes, it does. So I'm still going to factor out that 2. But now, because this has an x to the 3 and this has an x to the first, x to the first is the highest that both of them have in common, so I can take out an x to the first. Okay, so what does that look like when I factor it out? Just like we've done in all the other problems, a 2 divided by 2 is a 1. So I don't even need to write that 1 as the coefficient. I'm just going to be left with x squared because my exponent on top is 3, and in the denominator is 1. 3 minus 1 is 2. I'm going to have a negative 98 divided by 2. That's going to give me 49. In this case, my x's are going to cancel out because both of them have a degree of 1. 1 minus 1 is 0, so we're left with x squared minus 49. Here again, we have our difference of squares. So I'm going to have x being squared and then 7 being squared. So I'll end up with x plus 7, x minus 7. And all of this is going to be multiplied by 2x because that is what we factored out of it at the beginning. So once you factor completely, you need to rewrite that multiplied by the greatest common factor you took out. But you guys are pros already at finding difference of squares and perfect square trinomials. So it's just a little added step. You guys should have no problem.